So today what we're doing is looking at describing and graphing piecewise functions. So what is a piecewise function? A piecewise function, it's basically it's made up of two or more functions. Okay, it's made up of two or more functions. Okay, each part has its own domain. Okay, so each part has its own domain. Pretty simple. So what does it look like? This guy right here, this is an example of a piecewise function. So when you look at it, it says f of x equals, and there's three parts. This part right here is the first part, the top part, I guess you would say, is um, an absolute value equation, and you use this if x is less than or equal to negative or less than -3. The middle part you use if it's between -3 inclusive and 7, and then that's a quadratic, and then this guy is a square root function, and use that when it's bigger than 7. So when to do this, if you had to evaluate, it says f of -5. Would you use the top part, the bottom part, or the middle part? Well, -5 falls right here. It's less than -3. So you're going to plug in 2 times the absolute value of -5 minus 5. And -5 minus 5 is -10. So what's the absolute value of -10? That's 10 times 2. That gets you 20. Make sense? To do f of 2, you're going to actually, do you go in the top, the middle, or the bottom? It looks like you go in the middle. So it's like -2 squared plus 4 times 2. So when you do that, 2 squared is 4, so it's going to get -4 plus 8, and that's going to get you 4 again. And then for the other part, f of 7. So if you have to find 7, most people think you're going to plug it into the middle, but it's got to plug into the bottom because it's got to be greater than or equal to. So this guy, you can go square root 2 times 7 plus 6. So that gives me radical 20. And if I break down radical 20, I believe that gives me 2 radical 5. Right? So sounds good. You can probably work on the second one here. You can probably do on your own. You could try that. I would say you pause the video and try it, see what you get. This right here, remember, is the greatest integer, so that only yields answers that are integers. So why don't you pause the video, see what you get. Your answers are given right here, just in case if you want to check your work. All right. Now, graphing. Graphing looks a little different. I can show you how to graph it using Desmos. There's a way to do it in the graphing calculator as well, but you know, it's pretty easy. So let's go through it a little bit. So okay, so the easy way to do this, to graph piecewise functions using Desmos, is you just open up Desmos, and you say, okay, the first part, I'm going to get y equals, and I'm going to go to the absolute value of x plus 3, and I'm going to close that absolute value, and I'll say minus 1. And then what I have to do is I have to use curly bracket. So a curly bracket, I'm going to literally type in x is less than 0, and then boom. That gives me that part of the absolute value function. And then I hit enter, and I'm going to put the other part, which is 2x minus 5. And then it's over there, but I want to say that is going to be a curly bracket, and we're going to say x is, and it's going to be greater than or equal to, so you're going to go greater than or equal to 0, and then you put the close bracket in there. Now look at what happens. So then we're done. So return. Actually, I'm going to get out of there. So when you look at it, if you go right here, if I scroll, look at where I say x is less than 0 right there is undefined. See how it's an open circle? Because it pops right here at 0, it's -5. So you need to be mindful of that. So this is what our graph looks like. So if you're going to put that into you're going to put that in here, you can kind of like just kind of graph it a little bit. So ideally, I'm just copying the graph like we have here. I'm going to see this. This is important. It does this. This is an important spot. -3, -1. I'm going to put a dot there, and I'm going to put an open dot at 0, 2. So if I do that, I'm going to go over here. I'm going to go -3, -1. Put a dot there, and then 0, 2. I'll put an open circle. Just do something like that, right? And make this look like it's going on forever. And then the other part of it, this guy right here, 0, -5, and then it looks like it goes just past 2. It's like 2.5. So 2.5, 0, and 0, -5. I'm going to graph this. 0, -5. 1, 2, 3, 4, 5, and put a dot, and then a solid dot, and then 0, 2.5. Another dot, and there's my piecewise function if I graph it. Now the crazy thing is we talk about the domain. What is the domain? In this case, even though there's an open circle here, it can be 0 right there. So realistically, its domain, if I'm using set notation, is all reals, right? What about the range? It looks like it doesn't, it goes this way forever, up and that way forever, but it doesn't fall below this point. So I would say that that would be something along the lines of uh, y such that y has to be greater than -5, right? Now it talks about is there any discontinuity? Is there a spot where it is discontinuous? This spot right here, all along the vertical axis, there is a discontinuity. There's a jump. So yes, it is. It is at the x equals 0. And what is it? It's a jump. Okay, so that one is a jump. So that's how you graph a piecewise function. Why don't you pause the video, practice doing numbers 4 and 5 real quick, and then I'll come back and show you how to do number 6. So did you graph those ones? I believe the other, like 4 and 5, I think you have a domain for 4 is all reals, the range is all reals, and it looks like you have a jump. And then for number 5, it looks like your domain is everywhere but -3. And you actually have two discontinuities for this. You have an infinite continuity, like an asymptote at -3. You actually have a jump at 1, but that's okay. And your range is all reals. But I just want to talk about number 6. 6 is crazy because there's 3 parts, and you can see this right here. So we use decimals to graph the 3 parts. If we go right here, the first part looks to be linear. So y equals 3x plus 8. So y equals 3x plus 8. And this is good when you have squirrely bracket when x is less than or equal to -4, right? And then I also have when I have it equal to -1, and that's going to be when it is between -4 is less than x is less than or equal to 2. So you have that. So zooming out, you can kind of see what that looks like. And then the third part, the third piece of this is x minus 2, and then it's going to be squared minus 5, and that's good to go when it is x is greater than 2. So this is what it looks like. Now, when you look at it, you're going to get close here. This is a solid circle right there, right? This is open. This right here is solid. This right there is open. So that's how you're going to have to copy that graph over those key points right there. But more specifically, if you look at number 6, the domain, if you look at it, it's actually the domain is all reals. The domain can be the domain is legitimately all reals. You can have whatever you want. So from negative infinity to infinity. The range is also all reals. So from negative infinity to infinity. That's cool. How about discontinuities? Well, we actually have two jumps. If you look at the graph, we actually have two jumps. We have a jump here, which looks like we had x equals -4, and one at x equals 2. So those are our two jumps. So it's at x equals -4 and x equals 2, and both of them are jumps, right? So that's how you do the graphing part. You should probably pause the video, probably do number 7 on your own, and I'll talk to you in a minute. Okay, so 7, what did you get? Did you get something interesting? I think 7, you have, it looks good. You got 3 parts. You got linear, a cubic, and a square root function. So your domain is good to go. It's all reals. And your range, I believe, is anything less than or equal to 7. And you have 2 jumps. The 2 jumps you have are x equals -1 and x equals 2. So hopefully you did that and you're pumped up and you're ready to go. And I'll talk to you soon. And may the force be with you.